friends, I'm presenting my next video on the topic of Laplace transform point first shifting theorem. Uh, First of all, we see the statement of that first shifting theorem. If Laplace of f of t is f bar of s given, or we can obtain it, then Laplace transform of f of t multiplied by e raised to at, it is equals to Laplace of this function is obtained by replacing s by s minus a. Therefore, here we get f bar of s minus a. If it is plus a, here it is s minus a. Or if it is multiplied by e raised to minus at, here a is with negative sign, then replace s by s plus a. Therefore, this is the statement of that first shifting theorem. Then, how to identify where to apply first shifting theorem or not? Whenever any function f of t is multiplied by e raised to at or e raised to minus at, this multiplication by this term indicates that that problem is for first shifting theorem. Then we try to solve some simple examples. First, find Laplace of e raised to at into sin bt. Here f of t is sin bt. We know that Laplace of sin bt by this standard result, it is a, here it is b divided by a square plus b square, and we call this as f bar of s a. This is the first step. We have to obtain the Laplace of this function f of t. Here f of t is sin bt, and then by first shifting theorem, by applying first shifting theorem, Laplace of e raised to at into sin bt, by this theorem it is f bar of s minus a, and its value is obtained with the help of this f bar of s. Wherever s is there, replace it by s minus a in this result, and therefore we get, here it is b divided by s minus a plus b square. Required Laplace transform. Two steps only. First step, find the Laplace of the given f of t, and then apply first shifting theorem, get the result by replacing either s by s minus a or s by s plus a. Second, find Laplace transform of e raised to at, here I take minus at, into cos of bt. Once again, this f of t is multiplied by the term e raised to minus at, means this is the problem for first shifting theorem, and therefore once again applying the same steps, we know that Laplace of cos of bt, a standard result for this, it is s upon s square plus b square. Once again we call this as f bar of s c. This is the Laplace of that function f of t. Then by using or by applying first shifting theorem. I am writing in short form. FST stands for first shifting theorem. We get Laplace of e raised to minus at into sine of bt, cos of bt, by this it is s is replaced by s plus e in this f bar of s, and therefore it is equals to, replacing everywhere s by s plus e, we get the result as s plus e divided by s plus e whole square plus b square as the Laplace transform of this term. Find Laplace transform of e raised to minus 4t into t square. Here f of t is t square, suppose, then it is multiplied by e raised to minus at type of term, means it is the problem of first shifting theorem. This is the indication that it is a problem of first shifting theorem. Whenever any function f of t multiplied by either e raised to at or e raised to minus at, and therefore we have to apply this first shifting theorem. Once again, we have Laplace of t square. Here n is to positive integer, therefore applying this result, standard result, its Laplace is n factorial 2 factorial divided by s raised to 2 plus 1. 2 plus 1 we get 3, and we call this as f bar of s c. Okay, and therefore by using first shifting theorem, we get Laplace transform of t square multiplied by e raised to minus 4t. It is, by this result, it is f bar of s plus a. What is a here? A is here 4. And therefore, in this result, replace s by s plus 4 everywhere. And therefore, we have result as 2 factorial divided by, I am replacing s by s plus 4. We get a required result. Again, 2 steps only. Find the Laplace of the given function and then applying first shifting theorem, we can obtain the required result. Find Laplace transform of e raised to 3t into t raised to 3 by 2. Here f of t must be t raised to 3 by 2 multiplied by e raised to 8t type of term, means problem of first shifting theorem. Nowhere it is mentioned that we have to apply first shifting theorem. By identifying the term, we have to decide whether it is a problem of first shifting theorem or not. And therefore, once again performing the same 2 steps, we have the Laplace of this function t raised to 3 by 2. Here n is 3 by 2, not positive integer, therefore applying this result, standard result, its Laplace is gamma n plus 1, n is here 3 by 2 plus 1 divided by s raised to 3 by 2 plus 1. 3 by 2 plus 1 we get as 5 by 2. Then simplify it by this result, gamma n plus 1 is n gamma n. Therefore, I will rewrite this as n is here 3 by 2, gamma of 3 by 2, and divided by s raised to 5 by 2. Further simplification, 3 by 2. To find the value of gamma 3 by 2, write in this form n plus 1. Therefore, that 3 by 2 I can write as 1 by 2 plus 1 and divided by SS to 5 by 2. And therefore, it is equals to S 3 by 2. Gamma n plus 1 is n gamma n. Therefore, n is here 1 by 2. Gamma 1 by 2 and divided by SS to 5 by 2. It is equals to, further simplification, further simplifying it, it is 3 by 4. Gamma 1 by 2, standard value is root pi and divided by SS to 5 by 2. And we call this as f bar of s. That is the Laplace of the function f of t, say. Okay, and then applying first shifting theorem. First shifting theorem, we have or we get Laplace transform of this t raised to 3 by 2 multiplied by e raised to 3t as f bar of, when it is plus 80, we have to replace s by s minus a, and therefore it is s replaced by s minus a. A is here 3. And then try to get this value by replacing s by s minus 3, and therefore we have 3 by 4 root pi divided by, I am replacing s by s minus 3 and then raised to 5 by 2 is the required Laplace transform. Okay. Fifth, find Laplace transform of e raised to minus t into sine square t. Okay. Here f of t is sine square t, which is multiplied by e raised to minus t, and as it is multiplied by e raised to minus t, it is the problem of first shifting theorem. Therefore, once again performing the same two steps. In first step, we find the Laplace of that function sine square t. It is not coming under any standard form, therefore we have to convert it using standard trigonometric result. Sine square theta is 1 minus cos of 2 theta, therefore 1 minus cos of 2t by 2. Applying property of linearity, 1 by 2 constant outside, and then taking Laplace of individual. Laplace of 1 is 1 by s, Laplace of cos 2t s upon s square plus a square 2 square 4, and we call this as f bar of s, say. Okay. First step. Then by first shifting theorem, using first shifting theorem, we get Laplace of e raised to minus t into sine square t is equals to, replacing s by s minus, here it is minus, therefore replaces by s plus a, therefore s plus a, what is a here? Coefficient of t, 1. Okay, and therefore replacing s by s plus 1 throughout this, from this we get 1 by 2, 1 upon s plus 1 minus s plus 1 divided by s plus 1 whole square plus 4. This is the required Laplace transform. You can keep this as it is, or you can simplify it further by taking LCM or cross multiplication. Example, find Laplace transform of e raised to at into sine hyperbolic bt. Okay, therefore here that function f of t is sine hyperbolic bt multiplied by e raised to t, means problem of first shifting theorem. Therefore once again same two steps we have to perform. In first step I will find Laplace of sine h bt by standard result. It is a, means here it is b, s square minus b square, we call this as f bar of s, say, and therefore using first shifting theorem, Laplace of e raised to at sin h bt is f bar of, as it is plus at, replace s by s minus a, and try to get this value with the help of this, replacing s by s minus a, and therefore we get b divided by s minus a whole square plus minus b square. This is the required Laplace transform. Example number 8. Find Laplace transform of cos h t into cos of 2t. Here the function, suppose f of t as cos 2t and then it is multiplied by cos ht. It is not in that form of exponential e raised to at or minus at, but we can convert this cos hyperbolic t into equivalent exponential form, and therefore I will rewrite this problem as cos ht. I can replace it by what is the equivalent result? Equivalent result is e raised to t plus e raised to minus t by 2 into cos of 2t. Okay, and therefore it is equals to 1 by 2 constant I can take outside, and it is Laplace of two terms. What are the two terms? Laplace of e raised to t into cos of 2t and plus Laplace of e raised to minus t into cos of 2t. Okay, therefore this f of t is common in both, therefore we find the Laplace of that function. Therefore Laplace of cos of 2t by applying the standard result, it is s upon s square plus 2 square 4, and we call this as f bar of s, say. Okay, and therefore we find the Laplace of these two separately, applying first shifting theorem here also as well as here also. Therefore Laplace of e raised to t into cos of 2t by using this first shifting theorem, its value is obtained by f bar of s minus a. A is here coefficient of t 1, and its value we can obtain by replacing s by s minus 1 in this result. Therefore we get s minus 1 divided by s minus 1 plus 4. second. Okay. Similarly, we can find the Laplace of this once again by applying first shifting theorem. Laplace of e raised to minus t into cos of 2t is f bar of, here this is e raised to minus at type of term, replaces by s plus a, therefore s is replaced by s plus a is here 1, and try to get its value by replacing s by s plus 1 throughout, and therefore we get s plus 1 divided by s plus 1 whole square plus 4. Okay, we call this equation 3. And then these two Laplace we put here to get the Laplace of this, and therefore of this cos ht into cos of 2t using equation 1, it is 1 by 2. Laplace of this term, and Laplace of this term is equation 2, it is s minus 1 divided by s minus 1 whole square plus 4, plus Laplace of the second term, and Laplace of the second term is equation 3, and therefore it is plus s plus 1 divided by s plus 1 whole square plus 4. Therefore, with the help of all this example, I try to explain how we can use the first shifting theorem. Important one is here to identify whether it is problem of first shifting theorem or not. And how to identify it? Once again I will repeat. If any function f of t is multiplied either by e raised to at or e raised to minus at, then it is the problem of first shifting theorem. And its value is obtained by replacing s by s minus a or s plus a. In next video, I will discuss the second important theorem, that is multiplication by t raised to n to any function f of t. If you are watching my videos, please like it, share it, as well as subscribe my channel for new updates.